So this one, this is 12. I don't remember whose was whose anymore. This was in Sophia's. Kiara, that was yours. Okay. So this is the one where this is the square root of this, right? So I can use substitution. Square root of x becomes my a, and this is 4a squared plus 19a equals 5. 4a squared plus 19a minus 5 equals 0. And then I do first and last. 4 times negative 5 is negative 20. Factors of negative 20 that sum to positive 19. 20 and negative 1. Replace your middle term with them. And then factor by grouping. And then I get negative 5 and I get 1/4. Wait, what did I do wrong? Because neither of those are there. That would be helpful. So then I have to plug back in. A was this, right? So I have to say the square root of x equals negative 5 and the square root of x equals 1/4. This can never happen. Square root can never be a negative number. So x would equal this would squared. The 1/16. Yeah. The square root of a number can never equal a negative number. So you rule that one out. All right, this one. Okay, so for number 4, this is actually 2 perfect cubes. So you have to cube root, and then it's x plus 8x squared minus 8x plus 64. So then this is one of your answers, negative 8. But then this, you've got to use the quadratic formula on. So negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a, 8. 64 minus 256 over 2, and then 256 minus 64, negative 192, which would be 2 and 96, 332, 216, 28, 24, 22. So there's one pair of 2s. It's going to come to the outside with an I to get rid of that. Second pair of 2s and a third pair of 2s. So 8 plus and minus 2 times 2 times 2 is 8. I, there's only the 3 left underneath, over 2, and then this goes into each of these. So there's your other roots, the 4 plus 4i root 3 and the 4 minus 4i root 3. All right, 16, you're going to move this over here. So x to the 4th minus x, sorry, not 16, 6, plus x minus 1. Factor by grouping. Take out an x to the 3rd. And there's that perfect cube again. So this would be x minus 1. That gives you the positive 1. And then this cube root, that would be x plus 1, x squared minus x plus 1. That's the negative 1. And then quadratic on this. Negative b plus and minus b squared minus 4 times a times c all over 2 times a. 1 minus 4. Negative 3, and that's 1 plus and minus I root 3 over 2, which are the other 2 solutions. So it looks like your sign was just wrong on this. That negative 1 should have been a positive 1, and then it would have been negative and plus in between. All right, this one. So this one is tricky because when you use substitution, so if I do x to the 3rd equals a, I get a squared plus 7a minus 8. I factor it. And I get a equals negative 8 and a equals 1. But x to the 3rd equals negative 8 and x to the 3rd equals 1. And these are actually perfect cubes. So you have to cube root. And then this would be -2, this would be +1, and these you have to do the quadratic on. So -b plus and minus square root of b squared minus 4ac all over 2 times a. So I'd get 2 plus and minus square root of 4 minus 16 over 2, which is 2 plus and minus square root -12 over 2. This becomes 2i root 3 when you simplify it, and then it's 1 and 1. So that's this and this. And then here, -b plus and minus square root of b squared minus 4ac all over 2 times a. -1 plus and minus I root 3 over 2. And that's these two. They took out the 1/2, but you could leave it in as well. All right, this one, so I want to take this and substitute it in. So t to the 1/3 equals a. 49a squared plus 28a, and then add the 4. So this is actually, because these are both perfect squares, I would test to see if it's a perfect square. So this would be 7 and this would be 2, double the product, which is 14, and it equals the middle. So I can do square root, square root, square root, square root, and then the sign from the middle. Then solve, so I'd get 7a equals -2, and a equals -2 over 7. And you just get it twice. So then that equals your t to the 1/3. I'm going to raise each to the 3rd power. -2 times -2 times -2 is -8, and then 7 times 7 times 7 is 343. That's where that solution comes from. All right, so 1.6b is still titled Solving Other Equations, but this one is focused on radical equations. So the stuff we're dealing with today will either start with a square root or something that would resemble a square root, a cube root, a fourth root, that kind of stuff. So we're going to learn how to get rid of the roots and then solve. So we're going to isolate the square root. Again, it could be a square root, a cube root, a fourth root, whatever that is. We're going to get it by itself if we can. Sometimes you can't, but you're going to work if there's only one for it to be on the side by itself. And then you're going to square both sides of the equation to get rid of your square root. You're going to solve what's left. And then what's super important about these are like your extraneous root questions. You have to check these answers. And by check them, you just have to plug them in and make sure that whatever's underneath the root, you'd be able to square root. So you're looking for something that's a real number, meaning if I plug it back in and it gives me a negative, I can't do it. Okay, so because I couldn't square root a negative number. But these are also like the ones with the fractions where there's no warning about extraneous roots. You have to know to check them. So if your equation starts with a radical, you have to make sure you check your answers. All right, so the examples look like this, okay? Yours, I think on the first one, there's a couple of typos, right? Like the square root goes all the way across. So if you want to just correct it, like I know number 1 and number 3 at least, I know that square root goes all the way across. It should only be over the 15 and the minus 2x. So the goal here is to get that square root on the side by itself. So I could either move the x, but then I have a negative in front of the square root, so I would recommend moving the actual square root. So I'm going to add the square root of 15 minus 2x to both sides. And I end up with x equals the square root of 15 minus 2x. So that whole thing goes to the other side. Then I would square both sides of my equation to get rid of the square root. I get x squared equals the square root and the square cancel out, leaving with what's underneath. And then as soon as you see that there is an x and an x squared, that's your indication you're going to have to factor. So you're going to get everything back to one side and then factor. So I'm going to move the 2x and the 15 to the other side. And I get x squared plus 2x minus 15 equals 0. I'm going to make sure it's equal to 0 before I factor it, and I'm going to put it in decreasing degree order. And then I'm looking for factors of negative 15 that sum to positive 2, which would be what? Good. Positive 5, negative 3. And then I want to solve for each of those. split and solve here. And I get x equals -5 and x equals +3. So now this is what I mean by check. I have to come back, and I don't have to go full out and check. You could go full out and plug it in and make sure it equals 0. But really your goal is to just make sure that whatever's underneath here is greater than or equal to 0. If there's a negative under there, it would mean there's an I, and then you can't continue. Back in a check. So I'm going to take this -5, and I'm going to plug them back in everywhere there's an x. So I'd get -5 minus the square root of 15 minus 2 times -5 equals 0. And I'd get -5 minus the square root of 15 plus 10 equals 0. -5 minus the square root of 25 equals 0. And -5 minus 5 does not equal 0. So that is an extraneous root, and I don't keep it. Then I'm going to do the same thing with the 3. I'm going to take the 3 and I'm going to plug it in to both x's. So I'd get 3 minus the square root of 15 minus 2 times 3 equals 0. And I get 3 minus the square root of 15 minus 6 equals 0. 3 minus the square root of 9 equals 0, and 3 minus 3 does equal 0. So this is the answer I keep. So x equals 3 is the only solution to this equation. And remember, like, the instructions are just going to say solve. It's not going to hint you to the fact that you've got to make sure you check for extraneous roots. So be really, really careful. All right, go to 2. So what's the first thing you're going to do? Good. Move this to the other side. So I'd get x equals the square root of 3x plus 18. Now the sign inside does not change, just the sign in the front, because I'm adding that whole thing. Then I'm going to square both sides. X squared equals 3x plus 18. Get everything to the same side. X squared minus 3x minus 18. Looking for the factors of -18 that sum to -3. What are they? Good. -6, +3, and then split and solve. And I get x equals 6 and x equals -3. And then I have to check. So I'm going to start with the 6, plugging it into both. 6 minus the square root of 3 times 6 plus 18 equals 0. 6 minus 18 plus 18 equals 0. 6 minus the square root of 36, and 6 minus 6 does equal 0, so I keep that one. And now I check the -3. -3 minus the square root of 3 times -3 plus 18 equals 0. -3 minus the square root of -9 plus 18. -3 minus the square root of 9. -3 minus 3 does not equal 0. So that's an extraneous root, and the only one you keep is the 6. Questions so far? Yeah.
Is it always going to be that if one of the solutions is negative?
No. Because they're not always going to be just an x on the outside. So if you had a negative on the outside, it's going to cancel out the negative. Yeah. All right, look at 3. Now it's already moved, right? So all I have to do is square both sides of my equation. I get 4x plus 13 equals the square of 2x minus 1. What are you not going to do? Distribute the power. Don't do that, right? We have to expand and FOIL. So you can either first, outer, inner, last, or you can use your shortcut because this is a special product. The shortcut is square the first term, square the last term, and double the product of the two terms. So -2x times 2 would be -4x. If you don't remember that, just FOIL it out. It would be 4x squared minus 2x plus 1, and it would simplify to be the same thing. Now I'm going to subtract the 4x and the 13. These are gone. And I get 4x squared minus 8x minus 12. Can I do anything here to make my life easier? Good. Divide everything by 4. Because it's set equal to 0, I can do that. And because it's not a variable, I'm eliminating. So 0 equals x squared minus 2x minus 3. Now it's a lot easier to factor. Negative 3, positive 1. And then split and solve, and I get positive 3, negative 1. And then we check. Square root. 4 times 3 plus 13 equals 2 times 3 minus 1. 12 plus 13, square root 25 is 5. 6 minus 1 is also 5. That one works. Check the negative one. 4 times negative 1 plus 13 equals negative, or 2 times negative 1 minus 1. So here's what could save you some time. If I just work out the right side of this equation, I get negative 2 minus 1, and that's negative 3. Can a square root ever result in a negative number? No, so I don't even have to work out the left side of this equation. I know it's not going to work. Nothing square rooted is going to give me a negative number. So I rule out the negative 1, and I keep the 3. All right, step 1 for number 4 is what? Good. Add the 1 to the other side. Square root of 6x plus 7 equals x plus 2. Then I square both sides. 6x plus 7 would equal, expand and FOIL, or use your shortcut, x squared plus 4x plus 4. Subtract the 6x and the 7, and I get 0 equals x squared minus 2x minus 3, and I factor again. I get x equals 3 and x equals negative 1. Then I plug it back in. Square root of 6 times 3 plus 7 minus 1 equals 3 plus 1. God bless you. 18 plus 7 minus 1 equals 4. Square root of 25 minus 1 equals 4. 5 minus 1 does equal 4, so this one works. Square root of 6 times negative 1 plus 7 minus 1 equals negative 1 plus 1. Square root of negative 6 plus 7 minus 1 equals 0. Square root of 1 minus 1, which is 1 minus 1, and 0 equals 0. So this time we get to keep both. It would be entered. I think this is another one that's like separated by a comma, but you're just typing it in and it doesn't matter the order. I'll double check. Yeah.
Didn't you say if it was like a negative?
If you were trying to square root a negative.
Oh.
Yeah, so not a negative in general. You can have a negative answer. You can have a 0. You just have to check them. Super fun stuff, right? These take a lot of work. Yeah. Questions? All right, look at 5. This time there are 2 square roots. Okay, the goal is to get 1 to either side of the equal sign. The problem this time is that they're never going to be isolated. So when I move this to the other side, I get the square root of 2x plus 3 equals 1 plus the square root of x plus 1. Now when I square both sides of the equation, I actually have to FOIL out 1 plus the square root of x plus 1 squared. So the left side, it cancels, and I get 2x plus 3. That's the easy part. The right side, this becomes 1 plus square root of x plus 1 times 1 plus square root of x plus 1. And then you have to FOIL it out. You can use your shortcut here. We'll talk about it once I FOIL it out. I get 1 plus 1 times square root of x plus 1, which is square root of x plus 1, plus 1 times square root of x plus 1, which is square root of x plus 1, plus square root of x plus 1 times square root of x plus 1, which is just x plus 1. The square roots are going to cancel out. So I multiplied a square root by itself, and the square root cancels out. Then I combine my like terms. So I've got a 1 and a 1 here. So 2 plus, there's an x, plus, there would be 2 of these. So 2 square root of x plus 1. All of that equals 2x plus 3. Questions so far? So now I got rid of one square root, but the other square root's still there, right? Just when you thought it couldn't get any more fun, right? So we move everything again to the other side, keep that one square root on the side by itself, and then we're going to have to square both sides again. So I'm going to subtract the 2 and the x. I'd get x plus 1 equals 2 square root x plus 1. Now I've got 2 choices. One is divide both sides by 2 to get rid of the number on the front, but then I'm dealing with fractions on the left-hand side, and I would say avoid it if you could. The other thing is to square both sides of the equation at this point. Make sure you square that too. So the left side, I'm going to use the shortcut on. Square the first, square the last, double the product of the middle, or for the middle. On the right-hand side, this gets distributed. The 2 gets squared, and the square root of x plus 1 squared would just eliminate the square root, and I'd get 4 times x plus 1. So I'd get x squared plus 2x plus 1 equals 4x plus 4. And then I have to solve again, get everything to one side. Factor it. Split and solve.
One interruption is about
What? Okay, now we gotta plug it back into check. So I'm gonna first plug in the 3. Square root of 2 times 3 plus 3. Now you could plug it in anywhere you want. So you can go back up to the original. You could go to after you move the square root to the other side. Like I could plug it in this one or this one until I squared it and then I altered it. So, but until that point, you could plug it into either one of those. I'm just gonna go back to the original. So 2 times 3 plus 3 minus the square root of 3 plus 1 equals 1. I get the square root of 6 plus 3 minus the square root of 4. So square root 9 minus square root 4, which is 3 minus 2, and that does equal 1. So I keep the first one. And then I check the second one. The square root of 2 times negative 1 plus 3 minus the square root of negative 1 plus 1 equals 1. Square root of negative 2 plus 3 minus the square root of 0 equals 1. Ms. Ferrier, this is like the worst lesson ever. I'm here. Did you come to teach? They just noticed that x squared minus 2x minus 3 has come up like 4 times. All right, yeah. All right, so that one worked too, right? So we keep both. There's a couple absent today too, but it is. All right, you try 6. See how far you get. So I moved the square root of x minus 3 to the other side. I squared both sides of the equation. You end up with 2x minus 5 equals 1 plus 2 times the square root of x minus 3 plus x minus 3. Combine your like terms, and I'd get x minus 3 equals 2 times the square root of x minus 3. Square both sides of the equation. and you get x squared minus 6x plus 9 equals 4 times x minus 3. Factor and solve. We'll move everything to one side. Factor and solve it. You should get x equals 7 and x equals 3. And then take and plug that back in. So the square root of 2 times 3, well, let me do 7 first, times 7 minus 5 minus the square root of 7 minus 3 equals 1. I get square root of 14 minus 5 minus square root 4. Square root of 9 minus square root 4, which again is 3 minus 2, and that equals 1. So that one works. Then you go to the next one. Square root of 2 times 3 minus 5 minus the square root of 3 minus 3 equals 1. And I get square root of 6 minus 5 minus square root of 0, square root 1 minus square root 0, which is 1. And that one also works. So we keep both answers. Yep. I'll try. So this time with 7, it's already moved, right? And it doesn't matter if you move the 2 to the right side or you keep it with the left side. Either way, you've got a radical mixed with the number. Kiara.
I was just wondering, what would happen if like none of the answers?
All right, so then I'm going to square both sides of my equation. On the left-hand side, I would FOIL that out. So square root of x plus 5 minus 2, square root of x plus 5 minus 2, x plus 5 squared would be x plus 5. Minus 2 square root x plus 5 minus 2 square root x plus 5 plus 4. I get x plus 9 minus 4 square root x plus 5. That can go in any order. On the right-hand side, the square root of x minus 1 squared, the square root cancels, and I get just x minus 1. Then I'm going to move everything to the same side again except for the square root. So I'm going to subtract the x and the 9. And I get negative 4 square root of x plus 5 equals, these cancel this time, and I get negative 10. So the x's are gone. Now I can again divide by negative 4. I would just have a fraction on the right-hand side, but you can do that. Or you can square both sides. You just have to remember to square the negative 4. So negative 4 squared becomes 16, and then the square of the square root of x minus, or x plus 5 becomes x plus 5, equals negative 10 squared is 100. I'm going to have to divide by 16 so the fraction didn't go completely away. I get x plus 5 equals 100 over 16. They're both divisible by 4, right? Would be 25 over 4. So you want to reduce it. People see that in square root both. Don't do that. Like people see it, and for some reason, because they're both perfect squares, they'll square root it. Don't do that. And then subtract 5. So I get x equals 25 over 4 minus, this is 5 over 1. Yeah.
Why wouldn't you distribute the 16?
You can. You're just going to have to divide by it again at the end. You'd still get the same answer. And then this times 4 and 4 here, I'd get 20 over 4, 25, sorry, over 4 minus 20 over 4, and I end up with 5 over 4. So you can get fractional answers. You still have to check them. Square root of 5 fourths plus 5 minus 2 equals the square root of 5 fourths minus 1. Checking my answer here. So this again, this would be over 1 times 4 and times 4. This would become 20 over 4 plus 5 over 4. So 25 over 4 minus 2 equals, this would be 4 over 4. Square root of 1 fourth. That square root gets applied to both. So this is 5 over 2 minus 2 equals 1/2. This is 4 over 2, and I get 1/2 equals 1/2. Very rarely when you only get one answer does it cancel out, but does it not work? But it does happen, so you want to make sure you check. Okay, so we'll save 8 for Monday. Like we'll start by reviewing that one. We'll do that one on Monday. Because the next set look a little different, okay? They have different roots. So if I had a 4th root or a 3rd root, or if it's raised to the 1/3 or the 2/3 or something like that, you're still going to do the similar process. So if it's a root other than a square, you just raise that to the same power. So if it's a third root, I'm going to raise both sides to the third power. If it's a fourth root, I'm going to raise both sides to the fourth power, okay? If the expression is raised to a fractional exponent, you're going to raise it to the reciprocal. So that would look something like if I had x plus 3 raised to the 1/4, I would raise this to the fourth power, and these cancel, okay? So whatever the exponent is, you want to raise it to the reciprocal of it. If it was 2/3, I'd raise it to the 3/2, and it would still cancel to give me 1. All right, so look at 9. I get the cube root of 4x squared minus 4x plus 1 minus the cube root of x equals 0. These are actually, they look more complicated, they're actually easier. So I'm going to move this to the other side. Cube root of 4x squared minus 4x plus 1 equals the cube root of x. And then I'm going to cube both sides. The cube of the cube root eliminates the cube root, and I get 4x squared minus 4x plus 1 equals the cube root of x cubed is just x. Move everything to one side of the equation because I've got an x squared and an x, so I know I'm going to have to factor. Now you can do first and last here. 4 times positive 1 would give me 4. Factors of positive 4 that sum to negative 5, negative 1, negative 4. 4x squared minus x minus 4x plus 1. And I factor by grouping. Take out an x, 4x minus 1. Take out a negative 1, 4x minus 1. And I get 4x minus 1 times x minus 1. Split and solve. And I get 4x equals 1, x equals 1/4, and x equals 1. Here's the good news about the cube roots is there's not going to be extraneous roots. So you can check them to make sure your answer's right, but you're not going to have to check them to rule out an answer. So if the exponent is odd, if we're raising it to an odd power, a cube root, a fifth root, or whatever those, we don't have to worry about the extraneous roots. The extraneous roots are going to come into play with a square root, a fourth root, a sixth root, that kind of stuff, okay? So we get to skip that part of the step. It doesn't mean you can't plug it back into check to make sure you're right and you didn't make a mistake. Good morning. But at least you know you don't have to eliminate an extraneous root. So my answers here are 1/4 and 1. All right, so now look at 10. The 1/3 is the same thing as the cube root. So I can rewrite that as cube root if it's easier for you to understand, or I just bump this to the other side. 3x plus 7 to the 1/3 equals 4x plus 2 to the 1/3. And then I would raise each to the third power. And they're both going to cancel out. So 1/3 times 3 is to the first, and 1/3 times 3 is to the first. So this is just 3x plus 7 equals 4x plus 2. Subtract the 3x. 7 equals x plus 2. Subtract the 2. And x equals 5. Okay, look at 11. Now I've got the fourth root of x squared plus 6x equals 2. How do I get rid of a fourth root? Good. Raise both sides to the fourth. So the left side is going to cancel. I get x squared plus 6x equals 2 times 2 times 2 times 2 is 16. Subtract the 16. X squared plus 6x minus 16 equals 0. Factors of negative 16 that sum to positive 6. Go ahead, positive 8, negative 2, split and solve. And then these we check. So an even root we check. So the fourth root of negative 8 squared plus 6 times negative 8 equals 2. I'd get the fourth root of negative 8 squared is 64 plus 6 times negative 8 minus 48 equals 2. I get the 4th root of 16 equals 2, and 2 equals 2, so I keep that one. Yeah, so this would be the 4th root of 2 squared plus 6 times 2 equals 2. The 4th root of 4 plus 12 equals 2. The 4th root of 16 equals 2. And that does work. 2 equals 2. Your 4th root of 16, just use your factor tree. So this time you're looking for the number to repeat 4 times. So this would be 2 and 8, 2 and 4, 2 and 2, and there's exactly 4 2's, which means the cube or the 4th root of 16 is 2. So just break it down, because it should break down to be that number, whatever that number is, that many number of times. That's how you'll know it's right. Questions? Okay, so 12, now it's an exponential form, right? If I'm raising it to the 1/4, it's the same thing as the 4th root, so it's the same exact process. I'm going to raise each side to the 4th power. On the left-hand side, it's going to cancel out, and I just get 3x squared plus 52x. And on the right-hand side, I have 4 to the 4th. 4 times 4 is 16, times 4 is 64, and 64 times 4 is 256. Then I subtract this, 3x squared plus 52x minus 256 equals 0. Oh, I'm going to cheat. This factors, and then it would be positive 64 and negative 4. You'd have to multiply the 3 times the 256. You'd have to find factors of that sum back to 52. And then you'd have to factor by grouping. The numbers won't be that big on your test. Split negative 64 equals 3x. Divide by 3. Negative 64 over 3. And x equals 4. Go back through the process of checking. So 3 negative 64 over 3 squared plus 52 times negative 64 over 3, all underneath the 4th root, or raised to the 1/4 is the same thing, equals 4. So the 4th root of 3 times 64 squared. Over 9. 52 times I'm just going to use my calculator to save time. So this would be a negative 3328 over 3. Equals 4. 3 goes into 9 3 times, and then 40, 96 minus 30, 40, 96 minus 33 28. It's faster without my calculator. 768 over 3. And that's the 4th root of 256. And we just said 4th root, we did it up here, right? 4th root of 256 is 4. So this works. The 4 is a little bit easier to plug in. So the 4th root of 3 times 4 squared plus 52 times 4 equals 4. 4th root of 3 times 16, 52 times 4, 208, 4th root of 48 plus 208, and I'm back to the 4th root of 256. That works as well. So if your numbers end up, especially on WebAssign, because they generate like different numbers, if your numbers end up being that big, feel free to use a calculator to help yourself out, okay? They will not be that big on your test. where you wouldn't have a calculator? Questions on those? Okay, last set looks like this. So what's different this time than before? It's not the same anymore, right? So on one side I've got 2/5, on the other side I've got 1/5. If I raise it to the 1/5, does the exponent cancel on the left-hand side? No. So you have to just raise it to the biggest one, okay? So I'm going to raise both sides to the 5/2. So you're raising it to the bigger exponent's reciprocal. Now what happens on the left-hand side is they cancel completely out, and I'm left with just x minus 3. On the right-hand side, I have 1/5 raised to the 5/2. What happens to those? What do you do when you raise a power to a power? Multiply. So these are going to cancel, right? And I'm left with 4x to the 1/2. So what happens if we had reversed that? Is it easier to do x minus 3 to the 2/5 equals 4x to the 1/5? Now just raise it to the 5th power. Let's see what happens. What happens on the left? It's just x minus 3 squared. And on the right? 4x. So you can choose whether you do it to the bigger power where you'd still have to square both sides of the equation, because you could do it that way, or you do it to just the denominator, and then you'll be left with a squared. I think the second way is easier, but you could choose either way, okay? So if I'm going to do it that way, I'll erase this so we don't get confused. I'm going to raise everything to the 5th power. You could do it either way, but one way you're going to have to square again. These cancel and these cancel, and I've got x minus 3 squared equals 4x to the 1st. Then I'm going to expand and FOIL or use the shortcut here. X squared minus 6x plus 9 equals 4x. Then subtract the 4x. X squared minus 10x plus 9 equals 0. Factor. Factors of positive 9 that sum to negative 10 would be negative 1 and negative 9. And then split and solve. And I get x equals 1 and x equals 9. Now, if it's raised to the 1/5, what's the index? Like what part of the, the 2/5? What happened, what part of the 2/5 is the index and what part's the exponent? 2's the exponent, 5's the index, right? So the index is what you have to pay attention to as far as do I have to check for extraneous roots or not. If it's odd, you're fine. If it's even, you have to check. So because the bottom number, which is the index, that would be the one that's on the front. This would actually be the 5th root of x minus 3 squared, right? If I rewrote it without the exponent, it would be like that. So these, I can keep both. You can still plug them in to check to make sure they work to give you the right answer. But at least you're not checking for extraneous roots. Okay, last one. What would I raise both to? I'm raising both sides to the 4th. So the 3 gets the 4th and the x to the 3/4 gets the 4th. So be careful with that. If it was in parentheses, then the 3 would stay with the x. But because the 3 is not in parentheses, that 3 gets the whole 4. So this would be 3 to the 4th, 3 times 3 times 3 times 3 is 81. These cancel, I get x to the 3rd equals, and then 2 goes into 4 twice, and I have x squared. Now what? What are you not going to do? Divide both sides by x squared and cancel out the x squared. So you can't get rid of the root, right? You can't cancel out variables. But as soon as you see there's a 3rd and a 2nd, that means get everything the same side and try to factor it, right? So I bring the 81x to the 3rd minus x squared to the left. How do I factor this? Take out an x squared. 81x minus 1. Now what? Split and solve. So this becomes x equals 0, which is what you would have lost if you divided both sides by x squared. And then 81x equals 1, and x equals 1 over 81. And then my original question had an even denominator, so you have to check. So 3 times 0 to the 3/4 equals 0 to the 1/2. This one's easy. 0 does equal 0, so that works. 3 times 1/81 to the 3/4 equals 1/81 to the 1/2. And this is 1 over 81, the 4th root of that all cubed, and then the square root of 1 over 81. So this is 1/9, that's the easy part. The 4th root of 81 is 3. So this becomes 1 over 3 cubed, which is 1 over 27 times the 3 that's here. And I end up with 1/9 equals 1/9. So it works. I get to keep both. Yes, Kiara.
Oh, wait, never mind.
Richard.
When you're square rooting 1, do you have to put something like
No, only if it was x squared equals a number, and then you go to square root both sides, you put the plus and minus. So technically we would have done it here like with the 0. It would have been plus and minus 0, but there's no such thing as plus and minus 0. Samuel. To the right side? Yeah. I feel like this is like one of the most painful sections of the whole year. Okay, I promise they're not all like this.